let's see if we can take the indefinite integral of sine squared x cosine to the third x dx. And like always, pause the video and see if you can work it through on your own. All right. So right when you look at it, you're like, oh wow, if this was just a sine of x, not a sine squared of x, well that's going to be the negative of the derivative of cosine of x. Maybe I could have used u substitution. Likewise, if this was just a cosine of x, not a cosine to the third of x, I could have used u substitution. I could have said u is equal to sine of x, but I can't do that over here. And so the general idea is here, if one of these has an odd exponent, and you see that this one does have an odd exponent, the cosine has an odd exponent, what you do is you try to algebraically engineer this expression inside so that you can use u substitution. And the way that you can do that, if you have an odd exponent like this, is to separate out one of the cosines x and then use the Pythagorean identity with the remaining cosine squared x. So what do I mean by that? So let me just rewrite this. So this can be rewritten as sine squared x times, let me write it this way, times cosine squared x cosine x. All I did is I rewrote something to the third power, something to the second power times that thing to the first power, dx. And then this can be rewritten as sine squared x. And then I'm going to use the Pythagorean identity to convert this into a sine squared, or really 1 minus sine squared. So that, by the Pythagorean identity, is the same thing as 1 minus sine squared x. And then we have cosine x times cosine x dx. And now I can distribute this sine squared times 1 minus sine squared, and I am left with, let me do this in a new color, so this business right here. So now I'm left with the indefinite integral of, so sine squared x times 1 is going to be sine squared x, and then sine squared x times negative sine squared x is negative sine to the fourth. And then all of that times cosine x. All of that times cosine x dx. Now this is starting to look interesting because I have sine squared x minus sine to the fourth x, but I have the derivative of sine sitting out here. I have cosine x. That's the whole reason why we did this little algebraic manipulation. And so u substitution works out quite well now, because if we said that, let me do another color, I'll do purple. If we say that u is equal to sine of x, then du is going to be equal to cosine of x dx. And that works out quite well because we have the du right over here, and then this would be u squared minus u to the fourth, which we know how to take the antiderivative of. So we're in the home stretch. So we can rewrite this as the indefinite integral. Instead of sine squared x, we're saying sine is the same thing as u, so we can rewrite that as u squared minus u to the fourth times du. And this is pretty straightforward now. This is going to be u to the third over 3 minus u to the fifth over 5 plus c. And then we just do the reverse substitution, and then that gets us to be, instead of u, we want to put a sine of x there. So we're going to get sine to the third x, or sine of x to the third, over 3 minus sine of x to the fifth power. Let me write that 5 a little bit. Sine of x to the fifth power over 5 plus c. And we are done.